Thank you, everyone. So we'll continue. This is the last session in the series of 7 days for Agile Scrum. And we have seen in the last 5 days, 6 days, we have covered almost everything within the Agile Scrum, mainly the Scrum part of Agile. Now, today, we'll be going deep dive into Agile Stack, which is for customer interaction, consistent practices, Scrum adoption, and having the mentality of team first with evolutionary design. And then you can see the automated testing is very, very important as far as Agile is concerned. Without automated testing, it is impossible to follow Agile. And if we do so, we will be having many drawbacks without automated testing. So if I tell you the entire Agile stack itself is around automated testing. So yesterday we have seen like what is the good definition of unit test. So developer, whenever he is writing a piece of code, writing a unit test is a must as a process and as a best practice. We should write always unit test. Like more popular is JUnit in Java, which our project is using currently. And then we have seen what is integration testing, functional testing. Once the developer commits his code to the repository, and when it gets integrated with the different modules within the same project or application, then we will do system testing. And then regression testing is again important to see whether after fixing or after implementing one new feature or enhancement, whether we are not breaking the existing features. So keeping that in mind, this agility comes into picture. So our objective will be to enable the agility. Now here in the upcoming 2-3 slides, you will be seeing a pattern where in the left hand side or in the left column, you'll be seeing business value, current problems and solution. And in the right side, we'll be seeing what we are going to do. So the business value, our objective is catching defects early in the development cycle. Shifting quality to the left, we have discussed. Flexibility of product lifetime is what we are going to improve if we if we enable the agility in our team, and it is going to shorten the time to market. So development time will decrease, and then you can get the advantage of quick to market. Now current problem is before Agile, the problem was there's a big loop from QA to developer, and then QA finds one bug, developer fix that bug, and in turn he will create two more. So complexity again for for finding a defect will increase as the difficulty and the complexity in the project is going to increase. And then flexible applications, when we say, which means they are inherently complex. Also, if we don't have a proper mechanism and system, and frequently if we do code changes, it is going to break dependencies. Some interdependencies you will be having without knowing you, because we don't have test cases or something like that. And then we'll be in that bug life cycle loop only. Now the solution for all these current problems is, one short solution is to have automated testing. When we say automated testing, at least 90% is the code coverage which we are expecting, including the branch coverage and the line coverage. And as a best practice, few organizations say, suppose again, I will take a scenario where you have done the acquisition of one product from companies to companies. This is a trend we have seen. And if the code coverage is less, if the code coverage is just 60%, 50%, so we'll ensure that we are going to increase it. We'll keep some benchmark, okay, 70%, 75% of the entire code base, but at least the new development which developer is doing to have 99% of code coverage or 100% of code coverage. So objective is at least to have 90% of the code coverage with the automated testing. One example is, see here, you are having different stages and we'll see two scenarios. One scenario is where you are doing development without testing, without automation testing, without including JUnits or any sort of automation testing. We have different frameworks. Let's say for this example, unit testing itself, which is being automated. And the second scenario is where team is doing the development with all the test cases, with the automated test cases. So implementation wise, coding will take 7 days in the first case, but in the second scenario, it is going to take almost double, 14 days. Now, integration here will take 7 days, but with test, it is going to take 2 days. Why? Because integration, system testing and all will be very less, as you have already automated many things. You need not to bother about much functionality. Testing and bug fixing, this particular cycle, you can see here also there will be some reduction, like where the fixing was 3 days, now the fixing can be done in just 1 day. The testing effort was 3 days in the second cycle. Here you can see it as 1 day in the second cycle, because it is cycle testing, fixing, testing, fixing, testing, fixing. So instead of spending 12 days, you end up in spending just 8 days. So overall release time, if you see in the first approach without test also, you can see 26 working days as release day. And here with second approach, where we see that for coding it took more time, for almost 14 days, but overall release time is just 24 days. And it's one snapshot which we have taken from one of the application, where we found actually if the team follows approach one without test, they got 71 bugs into production. Whereas other team who followed implementing automated testing, they just got 11 production bugs, which means almost 85% decrease. So this example clearly demonstrate how important, how efficient it is to have automated testing when it comes to enabling the agility. Now there are two approaches. First approach is test last approach. What is test last approach? So business value which you are going to get with the test last approach is you are going to obviously catch defects early in the development cycle. The flexibility and the product lifetime is going to be improved, and again you will be having a shortened time to market. That is a development time. Now the current problem is, let's focus on the current problem with the test last approach. In the test last approach, when the bugs are going to be created, it's not going to do anything actually to improve the code quality. Only with respect to bugs I am saying, because they are going to take significant amount of time to manage and fix it. You are going to raise the bug, then you will analyze it and fix it, manage it. Second problem is, when the code is written and tested manually, in order to validate that particular functionality, you are again going to retest over time and time in manual fashion. So this is the current problem which is doing without test last approach. And then last is, when the test last generated tests are better than at least no test, but they are not as valuable as the test first. So we'll be seeing what is test first in the second slide. Now the solution for the current problem is test last. With this solution, what we are going to find is, in the last row you can see, commit as a team to discipline of writing tests, that is writing JUnits or tests, and we are going to ensure that writing tests are also very important as you are writing a production code. When that mindset, that thought process will be for the entire team. So we are not going to consider any feature to be complete without test. So as you commit to pay the technical debt, we called it as NFR, non-functional requirement, or technical debt, uh, if we are having application or if we are having code base where the code coverage is less than 90%, and so on. So overall meaning of test last approach is first you write a code and then you are writing unit test. Now better solution is test first approach. In the test first approach also business value is all the same. Now the current problem is test written. The current problem with the test last, or what we can see here, is test written after the code are less likely to return well or at all, because there the prime focus will be to the code coverage. And in test last, when the code design is affected by how it will be tested. So that is also second consideration. And then there is a distinction between writing a test to validate customer requirement and writing a test just to exercise the code, which means just to do the code coverage. Now better solution is TDD. So mind my words, TDD, sometimes they will say it as BDD, also behavior driven development. TDD is a concept which is known as test driven development. Before you write your actual code, you write your test cases, you write your JUnits. How that is possible we'll be seeing. So here we can see red green refactor process, and what this red means is uh, red means you are writing a test based on the requirement that will fail. Green means you will develop a code to satisfy the test so that it should get passed. Refactor means, okay, you have seen, okay, what is the gap? So you are going to clean up the code, test it so that you can make it more efficient. So that is how the TDD process looks like by implementing red green factor. In detail, we'll see the testing technique, like you would have heard about the stub or mocking the objects. So don't be afraid of writing a code that will prove our system works as a customer has requested. We'll design something and we'll implement it. If it is not making some sense also, that's fine initially when you are going to write a when you are going to follow the TDD approach. So stub is nothing but it is a portion of a code. It's a kind of a pseudo code which you can say, or it's a fake object that is helpful for us for making sure that tests run smoothly. So we will create stub and then we are going to replace it with an object so that we can test another object without any problem, because you will be having several dependencies. So you are going to break all those dependencies, system dependency with respect to the stub, which is kind of a fake code. Why fake code? Because we have not developed yet. So we need to have some proxy or something like that. So using interfaces in order to facilitate testability, that is one objective. Now test code can implement an interface and encapsulate the test data. So in order to do that, we are going to extend class and we are going to expose private method for testing. And then you can see the how we do. We are having many frameworks in if I talk especially about the JUnit 4 or JUnit 5, where you would have seen Mockito, Easy Mock, Power Mock. So all these frameworks are for mocking the services and all. So we are going to mock an object. Now that mocking an object means it is an object that is used to see that your test cases, your test is actually failing or not. For example, when you are going to mock a service to a specific endpoint, so that you can interact with your client class, that is the main objective. And this is going to serve as a replacement for your external dependency. in actual end-to-end coding, in actual end-to-end testing, we have seen in many applications, not only your app, now everything is into the microservices as the industry is trending. You'll be having several dependency on the third parties or on the libraries. How we are going to manage with all those? By mocking the services. So that is one way. Now there is a difference between writing a bug and writing a test. Can someone explain what is the main difference between writing a bug and writing a test? Any thought around this? Or if I ask you what is bug? What is bug?
It's an issue on the code that can affect the functionality of it.
Not desired behavior.
Code. Okay. Any other thing? Any other point someone wants to add? What is bug?
Could be also a not desired behavior. So maybe it's not on the code itself, but maybe it's not behaving as a business would like to.
Mm-hmm. Okay. Just a minute. Let me fix my speaker. Okay, done. Fine. And then by that time you might have read this slide also. So yeah, and it's correct whatever you are saying. Whenever we say like when to write a bug or when to write a test and what is the significance of this, like never in a sprint for functionality being tested. And what is okay before moving here, what is the difference between bug and defect? Any thought around, is bug defect same or there is difference between bug and defect?
I think, well, maybe I'm wrong, but I think the main functionality of the code still works with a bug, and a defect it won't even run, you know.
Okay. Any other thought from anyone?
Well, I think those are terms that are used interchangeably often. Very similar.
Okay. Similar in terms of dictionary language, it's kind of a similar is what we are saying. So see, what is our objective? Our objective is, as I said, shifting quality to the left. When your sprint is ongoing, when you are in active development, if you find anything missing, any issue, we can call it as a bug. That is a sprint bug. Okay. And by changing our code within the same sprint, in the internal testing phase, if we find it, we will see it as regression bug. Defect is something, that's why we say, if you remember the term as escape defect, there was one matrix. What is the escape defect rate or escape defect velocity also sometimes few people says, but defect is something which is now not in your control, which you found in the later phase of development or which is now into the production, something like that. So bug is something from the issue perspective or functionality perspective, bug and defect, you think it as same. Okay, there is a user validation or a form validation which is not working. That can be issue, that can be bug. But if it is within a development phase, we categorize it as bug, as a sprint bug. We won't say sprint defect. We'll say bug. For example, let's talk about manufacturing example. You are having some iron bowls or iron rings, and then for those iron rings, there will be regression testing, stress testing, load testing, performance testing, durability testing, physical testing, that how it is there. Then they will put in the machines and will be seeing, because some of the rims can be used in the bearing and maybe in some engines and all. So, but after all those phases, in case it reaches to the end customer, it reaches to some other vendor who wants to use those iron rings, and will say that ring is defective. Okay, means it's having defect. But once it is into the earlier, when it is into the manufacturing unit and all, if there is any issue, we'll say, okay, it is a bug, we should remove it. So that is one slight difference in terms of terminology, what I wanted to refer and use. So defect discovery response is to write a test that will expose the defect and alert your team member of the issue so that the defect can be fixed in the later phase of time also. When you are going, so when you are writing a good test cases, if there is any regression failure, that time also that can be detected. When it comes to the sprint, within a sprint we will say, okay, fix the issue and then forget it. We don't want to waste time no creating a issue over, say suppose if you are using a Jira uh, as a peer or as a QA, we don't want to raise a defect on the system and then want to propagate it. Oh, we are doing a pair programming, or we are testing on the developer's machine or in the development environment. We are no over a chat or over a call, we are saying, hey, this is a bug, you just fix it. So that person will fix it, so that defect is never raised. And then when it goes to, say suppose staging environment or pre-prod environment, and if you don't have time, the sprint is almost about to complete and it's last day of the sprint, then maybe that time you may no create some bug which may get spillover, so entire story is going to spill over. That is the concept. Now another thing is when to write a bug. When a feature is done and a defect is discovered in a later sprint, either by your own team or by our client. So if a defect is not a bug during development, because the feature is in active development and is not considered as a done. That is the reason we avoid no raising um, more bugs over any tool, but rather will give that response then and there, kind of in situ preparation to a developer or to your peer, whoever has been developing that functionality, so that he can fix it and then no put the code. Like the same thing we used to do in the code review. So while seeing the code review also, okay, there is a separate slide for code review, I'll be coming into that later. Now what is the value we are going to get? And in the previous slide also there was a hint, writing a bug versus writing a test. So writing a test is to reveal a defect that has lasting value, because when we run our test every time we build, the value increases over a time as we write more tests to cover more possible scenarios, where we can now discover more bugs earlier in the phase, hopefully, and fewer defects in the later production. Now consider scenario where you are having automation framework and as many possible scenarios and test cases you are writing, so that, like, and we know that, okay, we are having assertion, assert, true, false, equal, this and that, and we are doing this. So it is going to create a value later point of time where you are having CI/CD, continuous integration and development. I'm having a slide for that as well. That is only possible when we are going to write a good amount of test. So overall, we have just seen few slides for automated testing. Now moving to team first, focusing on the team. Now we have seen this term already, cross-functional team. Why cross-functional team? It's like a SWAT team where each team member is having their own expertise, and finally the objective is to become a full stack team member. Now the business value which we are going to get for by having cross-functional team is it is going to reduce your time to market by enabling true iterative and incremental development. Just imagine you are having gathering, analysis, design, build, test, and deployment phase within a sprint with the small cycles. And for this all 5 phases, if you have the expertise within your team, they are going to work by fully building small increments of the software piece at that time, which we can deploy at will, which means the shippable working code, working software. Second business value which we are going to get it, it is going to increase the flexibility by reducing the work in progress at any given point of time. Now the current problem, if you don't have cross-functional team, that is us versus them. Cross-functional Scrum team you are not having, then you are having a different DB team, UI team. Earlier we have seen, okay, UI team is separate, server team is separate, DB team is separate, QA team is separate. You have DevOps team or Cloud Ops team separate. Now what they will say, that there is an expert sitting on every site, means in every internal team, and you will mark a fence, a boundary, and then back and forth the things are going to just, we are going to throw it back from one boundary to another one. Hey, this is UI issue, this is some other issue, this should go to the support, or this should go to the, it's build issue, it's failing something in Jenkins, it's not my headache, we'll say something like that earlier. So documents are used, or we can say it's misused, to create an illusion of control while stifling real communication between project team members. Another problem with this was working piece of software are nowhere, and we can see that only when we are near to the end of development cycle or partially done, but that work will have no value because that concept will be lost. And expert typically work on multiple projects at one time, which is demerital to focus and efficiency. Because once we don't have a cross-functional team, whoever is expert, he will be working on multiple things. Okay, so that the focus of that particular person will be lost. Now the solution for this problem is to have cross-functional team where team is hooked together for success or failure. As I said, okay, if the cricket team wins or a football team wins, soccer team wins, is the entire team wins or entire team fails. And best example is with this example. It's overall team commitment, overall team's ownership for delivery of the project, for delivery of the deliverables. It's not like we are sitting in the same boat and one internal team, they are saying, hey, I am glad the leak is not at our end in the boat. You are drowning, and if there is a hole in a boat and 2 team members drown, the entire ship or boat is going to drown, and then you can see the shark. Sharks are ready. So it's better we should commit ourselves as a team commitment and the team ownership should be there, and that can come when we have a cross-functional team. As we have cross-functional team, so for code also we should have a collective ownership. The business value which we are going to get is, it is going to again reduce the time to the market, and it is going to increase the quality to the market when you are going to find the uh, integration defects early and often, and you can eliminate a larger portion of the traditional no, hardening of the sprint and the associated rework for doing that. And it's going to increase the visibility of the entire progress of the project by making it explicitly available for the development team and the stakeholder. How we are going to get this value is, we'll be seeing the solution, but what is the current problem? Every team member is there, and when you have certain boundary of, okay, this is my code, we see the developers develops the affinity towards some component, module, or some functionality. They will grow their expertise into that thing, and if the similar kind of feature, functionality, or the bugs or something comes, hey, you know, I know that account management. If something comes in the account manager, I will go and I will fix, or I will develop features towards the account management. If it is account creation, activation, this and that. Now we'll be having a territorial code practices, don't touch my code kind of behavior earlier. So because of that, if someone leaves the project, and we have seen the people comes and goes from one project to another project, shift from one or to another org, so that domain expertise will leave with that particular person, because now it was his territory and he was not allowing someone to work in that. It was having huge dependency for the project. The solution is to have collective ownership, where developer will need to modify or write a code, write a test for the part or for the thing which he has not developed or he has not written earlier. They cannot say that I am going to refuse to help my colleague. Sometimes, and we have seen this trend, when initially few developers are there, when they start writing a code, they will say, hey, you know, I am touching into this particular service class or a controller class, but or maybe into that specific private function or a function, where my job was just to write 2 lines of code, and for those 2 lines of code I can write JUnit, or it's already been covered. Why should I write JUnit for the previous code, whatever is there? He will think like that. If you are doing refactoring, say suppose if it is, one example is, this is a time zone converter. So at 3 places it is being used, and as a senior developer you are saying, okay, at the 4th place now I am pushing, introducing. Oh, better put it into some utility class, and from that utility class use it once, and the reference will be at 4 places. Now if the developer is going to move it to the utility class, and if he can now change at the 3 places where it is reflecting, that's good practice. But if the feeling is, hey, you know, I am not going to touch that, or I cannot have the team members, we cannot have a good collective code ownership. So that is one of the things which we'll see. The entire system must be running and integrated all the time. That is the main focus. So for a team also, team spirits, sportsmanship spirit is needed, and for the ownership also, collective code ownership is needed. And the important thing, as I was saying, CI/CD, continuous integration. With continuous integration, you are going to find those similar business values which we have shared earlier. And the current problem without continuous integration is, the integration is typically difficult and risky, where it requires multiple practices to buffer against uncertainty, because the moment you push another code, moment you push 1 or 2 additional feature, there's a high possibility of breaking something. So you will do system testing, integration testing, assembly testing. And as you develop more and more features, the more and more code is going to push into software. So it is going to increase the complexity over time, and the integration becomes very difficult. So successful integration precedes successful functional testing. That is the problem. So solution is to have integration testing. Now in the integration testing, we are going to maintain working software. So it must successfully compile, successfully deploy, and successfully test. So CI/CD pipeline, or it provides full working software at all the times. And there are some tools which we can use, and in our project also we are obviously using. So we'll be seeing in the subsequent slide what is that. So continuous integration is very important. It is the software development practice where member of team integrates their work frequently. Usually each person integrates at least daily, leading to multiple integration per day. And each integration is verified by an automated build, including test, to detect integration error as quickly as possible. If there is any test case failure, which means the build is not going to happen, build is going to fail, and the developer has to fix his own test cases which got failed. Or because of his new changes, there is a regression test case failure which happened, where some of the things he might have break. And if all the test cases are passed, then you can push directly into the production also. That's how the CI/CD always work. And CI/CD you can implement in all the phases, in the pre-prod development or and the production. If you have different development environment like sandbox staging or the UAT, you can still do there. Someone will have a dev environment or QA environment as well. So this is the model for CI, that is a continuous integration, where you can see the developers continuously commits the code to the SCM. SCM is nothing but a code repository, GitHub, GitLab, SVN, something like that. And then all the libraries you are continuously putting into the Maven, where you have all the dependencies. And as there you can see there is a Hudson CI server, and we can do with the help of Jenkins or Team City, and there are many tools which are available. So main objective is to have a continuous code inspection, continuous deployment, continuous load testing, performance testing, and all these things can be integrated with your continuous integration model. Second point is code review. So we are seeing all this in terms of teams first uh, part of the agile stack. So with code review, again the business values are many, like reduce the time, faster to the market, and you will find the defect early in this stage. It's going to increase the visibility of the functional code across the team, where you are going to facilitate the broad expertise, and overall it is going to improve the quality. Quality is the main focus for the code review, and consistently due to personal pride and pride of the developer also, that is also one of the objective. In my previous organization, we were using a tool which is known as Git Prime. You can Google it out. So Git Prime is a tool where it can give a overall efficacy of a developer, where you had a several matrices which can be got, like what is his active day per week, and how many lines of code a particular developer is committing, and all those things were there. But most important thing was PR resolution, that is pull request resolution. Like when the developer commits his code, when he is raising a PR, and once the PR is reached, how much time it is taking for first reviewer to give the comment, the second reviewer to give the comment, and then okay, if you are having a condition where at least two reviewers should approve it before merging it into any branch, say suppose a master branch or something. So how much time it is taking? If the code review is given, whether team member is incorporating those changes or not, how much is the acceptance of the code review comments. If the acceptance is suppose more than 80%, 90%, which means the developer is not writing very good amount of code where the frequent comments he is getting and he's incorporating. If there is no comment at all, if there is no review comments at all, there can be two condition. Either a super genius person who is writing everything writes so that you are not getting any review comments, or the review is itself is not happening. So if it is less than 30, less than 10 or 15% also, that's not good. So that tool will give you, okay, the this should be somewhere around 30 to 35%, and the entire PR resolution things will be there. So there are other things where we can see it. So developer will, as a pride, they will try to see, okay, my PR when it is rich, it should close first. I should go give more number of review comments and all those things will happen. So doing the code review is best practice. Now problem without code review. The current problem was when the code is written by a different developer, they will be having a different style or a mixed style for writing their own code. So in the code, you will be having a documentation comments or a Java docs that will be inconsistent and infrequently. So even the best written code has the defect, we can say, that cannot be identified by one single developer. So knowledge of the complete system and interaction is impossible for one person to possess. If unless and until he's having 3 years, 5 years, 10 years, or 15 years, 10 years into the same project, but that doesn't happen. You will be seeing technologies changing, the entire code base will change. So in other words, we can say it's better to have means it's one head is better than no two head. So like four eyes are good than the two eyes is what we say. The solution for this above current problem is uh, to have a code review as a pre-code check-in process. Without that, that should not happen. And our team is doing it very well, that okay, we are having two approvers to approve, then only it is going to go. But the problem which I am seeing currently is the PR resolution time that is taking, like one of the example I can see in case of Alfredo itself is okay, the 128 Jira number is still lagging and we need to push, as the example which we have seen. So code review has been rigorously studied in many experiments we have seen, and in the software development practices, it gives consistently result for drastically improving the code quality of the software product. Not only that, the another main benefit of doing code review is whenever any individual developer is working, he will be working in silos. So he won't be having full knowledge of the entire application because he is just focusing on one specific module, sub-module, or one specific functionality. But when he is doing code review, he is reading a Jira, he is seeing, okay, my peer has done this thing or not. You can have a quality QAWS quality walkthrough session. If there is any doubt, the person who is reviewing the code can have a quick sync up call with the actual developer. So he will not only get the domain and the functional expertise of that particular user story, but also he can see how that particular developer is writing a code. If that person is much experienced than this developer, he can give some valuable review comments for best coding practice. So we have a best coding practice template. If the reviewer is inexperienced than this, so he can learn from by seeing those PRs, and he can implement into his. So code review is the best practice which everyone should do. It is not, there is a misconception which we think that only team lead or only the senior developer should do the code review. No. Even if you are a junior, even if you are having a 1 year of experience, if you understand the code, that is fine. If you have any query, put it over the comments. That is fine. So code review is very important, we should do. And then there is a concept of pair programming. Mainly, it improves the overall quality of software while it is being built. So it's relate with the quality. It's spreads expertise across the team, because in the pair programming, one on one machine, two developers are working. You are having a co-located team, and then on your machine, another developer is also working. Together you are debugging. Together you are working on some piece of code. So the expertise is being shared across the team member, and it is helpful when you are doing a test first approach, that is a TDD development also. Now the current problem is developer will be seeing one or two ways typical, which we can think of every potential no option, means all the boundary conditions. But when you get insight from someone else, no, because it's all intellectual work which we do as a developer. So when you get some other thought process, because every time when we are trying to fix some problem, when we are trying to implement, there can be n number of ways, n number of approaches. Which approach is the most efficient way? Which is the better solution? That is our objective to see. But we won't be getting if we don't do pair programming. So another problem is developers look for a second pair of eyes when solving a problem. So the value of that pairing is obvious when solving difficult problem. Why not all the time? Okay, only when the problem is there we seek advice from the others. But if we practice doing a pair programming, for other things also we can no get the same advantage. So two developer working together always produce a better solution than either one would have produced individually. In the bold you can see, even if there is a big discrepancy in their level of expertise. Yes, there is the effect which is known as synergy. Have you heard the term synergy? There is an experiment which was done with the horses in a pull cart, in a horse cart. One horse was attached to the cart, and then it was measured how much tons, how much weight that a single horse can pull. And with the second horse also, they fixed the second horse and they have seen okay how much weight they can pull. So say suppose if it is 1,000, I'm just taking a term, if it is 1,000 with one horse, 1,000 with another horse individually, when they tie both the horse together, it was 2,500 or 2,600 unit of weight which they can pull together. So that is the best example of synergy. So synergy says 1 plus 1 is not 2, 1 plus 1 is more than 2. And that effect you can get from by doing a pair programming. So the solution for all this problem is to for worth overcoming the obstacles or exhaustion, personality, personal spaces, and all these things. It's a best practice to do, and the Agile promotes doing pair programming within the team. So now we are almost to the end of our slides. So do a little bit of everything at once. And that's what the Kaizen principle is. Okay, just 1% increment, 1% positive increment every day also if we do, at the end of the year we will be 37 times much better than what we are today. Personally, and in the same fashion, if we do incremental growth every day as a developer, as a tester, as a team member, as a designer, means developer, tester are not different team members in sprint or in agile. It's you are wearing a different hat. Once you are wearing a hat of designer, next time you are wearing a hat of developer, another time when you are doing a testing for your team member, you are wearing a hat of tester, or once you are deploying or doing something, you are wearing a hat of DevOps member. So it's different hats we wear. So for a developer and tester agrees to start with successful, add single product to the cart, design, code, and unit test as a developer mentality, design and automate test as a tester mentality, add to your build, and then agree to tackle adding multiple products to the cart. Again, second iteration, design, code, unit test, design and automate test, again add to the cart. Now agree or disagree and then remove the items from the cart. So agree to disagree, that is also fine, but do everything a little bit. That is what we says when it comes to the team. So we have seen almost everything from our agile stack. The last thing was the evolutionary design. That was the first slides when we started. What is the only code that is absolutely guaranteed to be completely bug free? The code you don't write. Correct. Or whatever you write, it can have some bug. It may break something. So the only absolute guaranteed code which is bug free is the code you don't write. So always remember, that's why automation, testing and all those things are important. So when you want to write a code, simplify, again simplify and simplify. So make it so best code is not very complex code which only you understand, with all the proper intention, alignment, with all the comments. If any less experienced person is also reading, without anyone's support, he can read it very easily. That's how the code should be simplified. And from there, we take this particular point, that is refactoring. When we say simplify means we are refactoring. Again, simplifying means we are refactoring. We have written our end objective was, okay, this functionality should work. I have written, I achieved the goal. Then we'll be seeing, okay, what is the time complexity? What is the space complexity? Can I rewrite it in a better way? So refactoring is always and always very important. Sometimes the library will get outdated, upgrading the libraries and all those things. So the business value you will get from refactoring is it is going to increase the flexibility and the length of the product lifetime by enabling and encouraging developer to change the design of the system as needed. Because so in our current project, what we are doing is from JUnit 4 to JUnit 5, we are doing the upgrade. Why? Because technology is changing, jars are changing, libraries are changing. When the code was written on the Java 7, it was there, but when you see some more functionality, the streaming APIs of the Java 8, you rewritten those things for getting better efficiency in the Java 8. Okay, that is one example. Another business value can be quality to market improves. Refactoring is always with respect to the quality, and the costs are reduced because continuous refactoring keeps on no a design from degrading over time, or you are going to become outdated. You means the product, the application. So we are going to ensure that code is easy to understand, maintain, and change. If the software is working, if the product is working, even though development phase is completed, in the maintenance phase also, you will be having some requests, some enhancement requests, something which you want to maintain. And then if you want to give it to some new tenant or new customer clients, then also you need to do some customization and give it. So continuous refactoring is always important. Now the current problem is, so the pattern which we are following is we are seeing what is the business value, the current problem, and what solution this refactoring can give. Bud means big upfront design is our friend, because it's fun to design an entire new system, but it's really impossible to able to define the ideal solution ahead of time. Okay, something if you want to start from scratch, if we forget about the time constraint, it's fun. to do it. But whatever is there to maintain that and to enhance that, that is a difficult. Now, neglected software typically becomes fragile over time due to lack of refactoring and too many bad it applied. How? Because you see, always there will be a security threat if we are not going to make ourselves updated. That's why you can see majority of the security testing when you do 90% will be upgrade the jars, upgrade the libraries. Why upgrade jars and library? Because when we are developing a code, we are obviously using many third parties, libraries. And those third party libraries are maintained by some organization, some company, some development team. And if they are not going to upgrade themselves, the hackers, crackers, attackers, they are going to attack that particular version. Now, in case if that is an attack, so one of the best example is the Log4j recent upgrade, which across the industry everyone has done. So they are going to upgrade their libraries. So when they are going to upgrade the libraries and we are having the upgraded version available, so we should also upgrade. Second problem, third problem is when the code is duplicated to avoid touching critical, uh, and then working code due to the lack of test coverage and all those things. When you are not going to maintain it, you are going to find all these problems. Keep on adding the code. So requirement change and the current solution is no longer a good one for a new problem. Whenever you are designing a system, when the software has been developed, you'll be having some use cases, some business rules, uh, which was needed at that particular time. Now, as the time pass on, there will be new requirement or the marketplace is going to change. So we need to adhere with all those things. So that's why the it's better always to have upgraded code. So solution for all this thing is make this refactoring as one of the best practices, and it is a disciplined technique for restructuring an existing body of code by altering its internal structure without changing the external behavior. This point is very important when I say. Just excuse me, my daughter is continuously. Just a minute. So I have to close my door, and sometimes she comes and she keeps on banging on the door to open it. Okay. So we are almost at our last couple of slides also, which is left. Like simple design is another another concept in our evolutionary model, which we have seen. So when we keep design as simple, not a complex design, it is easy to maintain and all. It reduces time to market and the cost of the software product because the team does not pay for what it does not need. It increases the product lifetime because the design is less complex, it's easy to understand, and you can keep on modifying and for the ongoing change, and one team, another team, and so on, the teams can um, take it. The current problem is if your system is not designed, feedback between the developer and customer is infrequent because of large delay between the requirement and the working software and all those things. And that's why the complexity increases. An over designed application takes significant time for a developer to understand, and due to that the built-in abstraction, uh, even that is never used, whatever they think. The third problem is design complexity has a high cost That is space every time a developer has to understand. I have to do something as a developer, and for me the system is super complex. Just to find out no where something is there when it is very difficult. So every time that specific time is lost to understand, and that involves the effort. To test the complex code and complex design, it is difficult. And if the complexity is for tomorrow, we start paying the cost today. But what if tomorrow never comes? Okay, we will create some very complex system by complex design by thinking, okay, tomorrow that is going to, those features are going to come and all. So all these things are current problems. And the best solution is keep it sweet and simple. That is the KISS principle. So make your design very simple. Determine what is the solution of today's problem. Focus on that particular thing. Design your feature. When it comes to Agile, that's what we say. We won't go on a big bang. Design for your feature. Have that flexibility so that we can adapt and we can plug in the things later point of time, and have a evolutionary design model for all the features that customer values and needs today. So adoption requires suspending your disbelief for several iteration until the value of that practice is clear. So best thing is to keep design simple. And this is the final slide which says you are not gonna need it. That's the Yagni principle, which refers to the temptation to write a code that is not necessary at the moment but might be in the future. Okay, so we'll think, okay, this feature, okay, I need to include this feature, I need to include, and because of that temptation, sometimes we do it. So why it matters? It's time spent on future feature is taken from adding, testing, or improving necessary functionality. Unnecessary new features impose constraint on what can be done in future. So an unnecessary feature now may prevent implementing a necessary feature later or make it more difficult. That is the reason in Agile we talk about MVP. In Agile we talk about the prioritized thing which is necessary. The features which are not necessary, we won't bother about that in the current sprint or in the current development. Until the feature is actually needed, it is difficult to fully define what it should do, how to do the testing, and if new feature is not properly defined and tested, it may not work right, even if eventually that is needed. So this Yagni principle is very important, where implementing. Okay, just a minute. Hey, hey, hi. Okay, guys. Let me take my mic. So we are almost for the completion. So main thing is, you don't need it, don't do it, because it's Yagni. That is the concept which we say. So fully we have covered everything from the Agile stack perspective. And the team's best practices we have seen is just a recap, like automated testing first or last. We have to see cross-functional team. We have seen collective code responsibility, continuous integration, code reviews, paired programming, refactoring, simple design, and finally the Yagni. So if we recap everything, automate everything what we can. The more we automate, it is easier. to have it tomorrow, and then we can add more values to the product and deliver it back to the business. Team first is the concept which we have seen, that we are on the same team, same goal. It's not like, okay, your side of the boat is having holes, so why I should bother. So the more we think about each other, the overall quality of our personal contribution will rise. The team and the product will be the world class, super class, and you are going to get those things. And then finally, the simplicity we have seen with the KISS principle, that is keep it sweet and simple. Put our best effort in terms of quality, flexibility in our work that is immediately before us, and leave bothering about tomorrow for the future. And this is the last final slide. Test early and often, and the root cause of most of the project failure is the poor health of the software, that is lack of early stage unit testing. And the Pareto principle says that 80% of the time spent is only on the 20% of the work. So that is the thing which I want to convey. And now this is at the completion of our final 7 days of Agile Scrum training, and I'm opening the platform for any queries if you are having, or any feedback which you want to give for the 7 days, whether it has added value to you or not, whether all those principles, practices which we have seen, and if you are going to implement it into your development in your project and product, how that will be. So last 5 minutes giving to all of you for the same thing. Any queries, comments, feedback, team?
Well, I think it is a good refresher of uh, principles that I think we all have heard about, but maybe we don't always put them into practice. So yeah, I think it will help us to approach the work with a fresh mindset, and try to analyze on the things that maybe we could improve by applying these concepts and principles. So yeah, it never hurts, right, to review all of this, because that's how we're aiming to work.
Sure, sure, Carlos. Thank you. Any other last comment before we call for the day? Okay, thank you guys. Then we'll meet tomorrow for our new series on the load performance testing with JMeter and BlazeMeter, same time. Wish you a very good day. Thank you, everyone.
Thank you, sir. Good day.
Thank you, sir.
Good day.
Thank you, sir.